Ever wonder how a breakthrough idea actually becomes reality? Hi, I'm Susan Lindner, and this is the Innovation Storytellers Show, where I sit down with the change makers behind the world's most inspiring innovations to learn how they did it and the stories that help them make it happen. If you've ever had a big idea or want to tell yours in a more powerfully connected way, you're in the right place. I promise you'll get new ideas for how to tell a better story to your audiences too. So let's dive in. Hey everybody, welcome back. I'm Susan Lindner, your host of the Innovation Storyteller Show. Today is going to be one that this is a conversation that you will look back on over the next 3 years and ask yourself, how did I not know about this when I first heard this podcast? Part of what I love doing on the show is introducing my listeners to brilliant new ideas that are breaking all around you by some of the people who are leading the charge in innovation and change around the world. And that's why I'm so excited that my guest, Jesper Kamp, is joining me today. We had the good fortune of meeting when I was in Copenhagen for TechBBQ, surrounded by about 10,000 entrepreneurs, innovators, VCs, investors, corporate types who are looking to find out what is the latest and greatest happening in innovation in the Nordics. And Jesper and I had the opportunity to meet up at the Niels Bohr Institute. And if you're a physics dork like me, then you would have been just as overwhelmed and thrilled to go into an institution that has really led the charge in what is modern day physics. And so this is not a nerdy discussion about physics. This is a conversation about quantum computing and what you need to know as an innovator about how this new technology is going to be shaping your world over the next 3 to 5 years, whether you want it to or not. We're not talking about AI today, although that will feature in some of the conversation. But what we want to talk about is the raw computing power that is about to shift how we analyze data, how we create new products, how we begin to solve problems, and really look at the world through an entirely different lens, thanks to the speed and breadth of quantum computing. So Jesper Kamp has worked at the intersection of geopolitics, international affairs, tech, and innovation for more than 25 years, both in the private and the public sector. Jesper currently has the great pleasure of being the regional director of Europe for atom computing, which has developed and produces the world's most powerful quantum computer, and is involved in a host of European government-related activities, I'll say, that focus on getting this incredible technology out into the world. Jesper, thank you so much for joining me. I'm so glad we got to continue this conversation after meeting in Copenhagen.
Well, thank you very much, Susan. I'm super happy to be on the podcast today. I'm really excited to talk about this.
Yeah, so let's get into it. Well, let me ask you first, how did you walk into, through the innovation door? Because nobody makes their way in through the front door, Jesper. So how did you find your way into innovation? What's your story?
Well, to make a long story short, I worked for the Ministry of Foreign Affairs, or what would be in the US called the State Department, for over 20 years. Started as a commercial officer, worked myself up to ambassador.
Ambassador to where, Jesper?
Ambassador to a lot of countries in Africa, and most recently I was the Consul General in Silicon Valley, out of Palo Alto, where we both have a Consulate General, and we also have Innovation Center Denmark, and that was the most recent 4 years. I also worked with innovation for over 4 years in China, out of Beijing. The embassy there. So I have a breadth, and again also in Turkey, the same thing. I was an ambassador at that time. I was head of mission in Turkey and deputy of commercial affairs and innovation in China. But making my way in was through diplomacy. I came in through diplomacy. The Danish Ministry of Foreign Affairs and government has been so visionary that we have 7 innovation centers in the most, at least to Denmark, the most relevant innovation hubs in the world. And I've been fortunate to be part of several of them, both on the inside of the State Department or the Ministry of Foreign Affairs, but also at the postings. Silicon Valley, I think, is and was both our first innovation center globally, and it is also now or currently the biggest. I like to say that Silicon Valley is probably the single biggest innovation hub in the world. There's probably people that disagree with me, but I think the Bay Area, it just produces something special and has something special to it.
I mean, realistically, Jesper, like what would rival that? What do you think is the counter argument? If it's not Silicon Valley, where is it?
Yeah, China is also extremely innovative, I would say. We had a larger, now not quite as large innovation center in Shanghai, but China is also very innovative. It doesn't, however, have the same concentration in a small area as Silicon Valley does. So, but China for sure. Besides that, I can't really think of it because the other areas are much more thematic focused. So life sciences in Boston, cybersecurity in Tel Aviv, and of course also other areas. Other areas, but they're much more where Silicon Valley has almost the width and breadth of all the current high priority innovation areas, from longevity to AI to quantum to robotics, whatever it may be.
Yeah, fair enough. So you're in the State Department of Denmark, essentially, right? And you find innovation through diplomacy, right? You find like as the era is changing, right? It's the late 90s, it's the early 2000s, and suddenly the world is becoming internet focused. The world shifts and we're becoming digitized, right? And our countries are becoming this way and our technology is driving that. And so how are you making the leap to the private sector from the public sector? Or what did that transition look like for you?
Well, the transition, my most recent transition looked like I had been posted abroad for 15 years back to back.
Wow.
China, Turkey, Nigeria, US. So very different places to live and work, but all very innovative places. Even Nigeria, extremely innovative in Lagos. And as I saw myself and the family wanting to return to Copenhagen after having been abroad for that many years, I started to look for something that was more innovative because I really thrive on the energy that comes in the innovative space, which is very often connected to entrepreneurship. And found Atom Computing, connected with them, and yeah, long story short, here I am today. But it was a very good process, but fantastic, and very honored to be able actually to end up in the quantum industry. I had been working with it for the last 4 years, where quantum had been gaining speed, but now to be in it and to be able to be part of connecting both the Danish and the European and international ecosystem is a huge privilege in a sector that has so much focus and potential.
Yeah. So I want to get into Atom in a moment. I just want to do a little bit of background for my listeners. So for me, I'd heard about quantum computing, but didn't really know what it was. I knew it was kind of high speed computing is what I thought of it. And your basic computing starts off with zeros and ones is binary computing, right? Is going through these very quick computations. And from the computer you had back in the 90s versus the computer that you have today, its speed, its size, its ability to do incredible things has shifted since we had AOL accounts, right? And we were downloading the internet on CD-ROMs on our computers, right? Life has changed. In the next shift in the world of computing really came with high performance computing, where you could tag together several supercomputers that would process lots of information quickly for you. And Hollywood is famous for using high performance computing right? Trying to get vast, huge images, right, that we could process digitally and then show on a screen. And many other industries used high performance computing to try to get that speed to process information, to store information, et cetera. Quantum computing is this next level. And I really, I think we were both at the Bifrost Summit together in Silicon Valley earlier this year. I was giving the keynote at that conference, but I stuck around to make sure I heard the quantum panel. And I have to be honest, I was in America, we say I was white knuckling it. I was holding on with both hands, trying to let the information go into my brain because it was so technical. And there were guys there from NVIDIA and I think from Microsoft who were trying to explain quantum computing to the rest of us. And I was digging in my brain to get back into 11th grade physics to figure out exactly what was happening. I come back to my hotel room and I was like, okay, I need to get a little bit clear on what quantum computing is. And so for my listeners who haven't had a lot of exposure to it yet, this is a new type of computation that uses the principles of quantum mechanics to solve really complex problems much faster than classical computers. And instead of using bits, these zeros and ones, right, that we understand from regular computing, it uses quantum bits or qubits, which exist in multiple states at once, right? It's not just this binary through this property called superposition. And quantum computers utilize this theory of entanglement, right? That the information that's being provided to you doesn't actually exist in silos and actually interacts with one another and feeds off of one another. So these qubits become linked, they influence each other instantly. And so you are able to do this massive parallel processing at the same time, which gives you this ability to tackle problems that have been intractable and very difficult for most of our lives. It's taken a lifetime to process some of the data or to work on some of the problems that we've had over time. But now these very powerful quantum computers are going to allow us to do that. Did I get that right, Jesper? Is that?
Yes, again, like you, I'm not a technical person, but that would be my way of explaining it too. And then
Yeah.
just adding then there is, just like when you had the VHS and Betamax videotapes, and you probably even had more Super 8 and all other things back then. There's several technologies, ways to do this. Photonics, spin ions, neutral atoms, and so on. Who will be the winner of that race remains to be seen, or maybe there will not just be one winner. Maybe there'll be several winners if you have to pick winners, depending on is that quantum capability going to fit in your phone? Is it going to be a supercomputer? Or we will have to see. We're still in the very early stages of quantum computing.
So, and for our listeners, the way that quantum computing is used, Jesper and I were just talking before we hit record about an example in the pharmaceutical industry, right? So suddenly with clinical trials, you're looking under a microscope and you're trying to figure out whether or not this molecule can do this thing or whether or not this other molecule would be more efficient to do that thing. If we're looking for a cure for cancer, quantum computing will very quickly help us ascertain and see live, right, which of these molecules will be more effective against this particular form of cancer or this particular stimuli. So it's just, we can actually watch in real time as we run through these cycles, right, these experiments to see what could work and what could work most quickly. So in theory, it has the ability to accelerate virtually every kind of big question that we've been asking out in the universe for a good long time.
Yeah, a lot of big, you could say, compute problems, and we have conventional compute today that cannot be solved by that alone. In the future will most likely be processed or computed in a hybrid version between a GPU and a QPU, so a quantum compute unit, where you will most likely process the data in the conventional compute. Once you have reached the limit to what you can process there, you will send it to the QPU, who will then process it even deeper. And then once it's finalized, the final result will be most likely sent back to the conventional compute again. But the concept is that they complement each other, the two forms of compute, rather than necessarily compete, because one has its advantages over the other one and the other way around. So very complementary.
Yeah. So we started this conversation and you are now at this level 2 quantum computing, right? So can you walk us through the levels a little bit and where if you don't know your history on quantum computing, just give us a little backstory on how this has evolved and what do you see that's coming really that's on our doorstep right now?
Well, I would say that the levels, you probably have level 1 to 5, and people argue, because also the different technologies, we all work with the qubit concept, but they also, we have different, because we're still so early, there's different standards of describing how it works. With still, there's not necessarily an industry standard for everything yet, but that's like programming language and all these things. So, but that's coming. So we most have level 1 computers right now, which have what we would say probably up to 100 physical qubits and maybe up to 10 logical qubits. And that refers to 10 qubits that are able to interact in that entanglement that you described earlier.
Yeah.
A level 2 is, now I'm saying around 1,000 physical qubits. Actually, our current is more than 1,200 physical qubits and 50 logical qubits. So we have 50 qubits which can interact in that entanglement. Level 3 would then be 10 times that, so around 10,000. Level 4, around 100,000. And level 5 would be in the millions. And once you're in the millions, yeah, again, I'm not the technician, but then the limitations really end to what you can compute, I think, as I've been explained. I think the limitations, once you have what we call a utility scale quantum computer combined with the current supercomputers or the supercomputers in 5 to 10 years from now, be more of the human mind and of the capabilities of how good are you at writing the algorithms and the programmings to the output you want from the computer, because combined computer, and that's in citation mark, there's almost nothing you won't be able to compute, but we have to learn how to use it also. That's also a process, which is why it's super important that we today start educating also the workforce around this.
Yeah.
Programmers, hardware engineers, laser engineers, optic engineers, all these skills and trades, quantum theorists. There's really a huge lack of talent in the industry around the world.
So, for my listeners who are product managers, product marketers, chief innovation officers, and their team members, what do they need to know about quantum computing today and how it will affect them? What should they be thinking about?
Well, I also had the pleasure of working a lot with AI for the last 2 or 3 years, and I would say it's the same as we've preached about AI. If you're not already involved in AI, it may with your business, especially if you're a science and research intensive business, even more so when it comes to quantum, you need to start looking into it, because the quantum conventional compute hybrid is coming faster than we all expect, which then means that potential for industry disruption, whether you're in molecules or data or life science or wherever you are, is extremely high. You see a lot of corporations that have great foresight. They're already playing with quantum now. How do I describe my challenges, my use cases? that I would like to compute once the compute power is there. How do I write the algorithms? How do I get my organization to work with quantum? They're already starting those in small teams in their businesses, because once the compute power is there, you need to be ready. If you're not ready, some industries you may already be disrupted.
Wait, so
Because
can I just ask a question? How do you get access to a quantum computer if you're a scientist at Pfizer, if you are, at NASA? How do you get access to a level 2, the brilliant quantum computer that you're creating in Copenhagen right now?
Well, the one we're creating here or installing here will, unless we get leapfrogged, most likely be the first commercially available level 2 quantum computer.
So do I rent space? Do I rent time? Is that how I do it?
Well, it's an initiative by the Novo Nordisk Foundation and the Danish Sovereign Wealth Fund, and they framed it around an organization that they call Q North. Q North will give access to this level 2 computer to all the Nordic countries. So scientists, startups, corporations, and so on. Whether that scope will expand, I will leave to Q North to define, because that's not, we're the technology provider together with Microsoft, which is our partner in it. So I do believe, so there's plenty of not plenty, but there are level 1 computers out there where you can start testing how to write algorithms, how to work with quantum. The level 2 computer, but that's more at a theoretical level or science level, where at a level 2, where you have 50 logical qubits, you have the likelihood that you can produce. Of course, the higher the computer, the higher the likelihood of you can produce something of value, both from a scientific perspective, but also from a monetary perspective if you're a corporation. And as we go to a level 3 and level 4, that output is just going to increase massively.
Exponentially, yeah.
So it's limited now. To here, I know there's probably a lot of our competitors that are working on similar things, both on their own technology and with other countries around the world. But for now, this is the only one that we know of, level 2 with 50 logical qubits.
Wow. So, and what is Adam's role in tell us a little bit about Adam and how this company got started and where you are now.
Well, Adam got started, I hope my CEO is not listening. I think it got started 8 years ago in Berkeley by the founder and co-founders, Ben Bloom and Jonathan King. They've taken it on this massive journey over the last 8 years with a strong focus on being able to provide, you could say, qualitative quantum computing and scalable. And currently, the scientific papers supporting neutral atoms shows that neutral atom, which is a technology we work with at Atom Computing, is definitely one of the front runners in the sector, and that it is highly scalable and reliable technology to work with. So we hope, that next generation, we're on a level 2 now. Next level 3 is around the corner. And around the corner, we're not talking 5 or 10 years. It's definitely less than that, probably somewhat less, but it remains to be seen. And yes, we are, as I think all quantum compute companies, focused on a single technology because it's extremely complex. So we are, you could say, hyper-focused on neutral atoms at Atom Computing.
Yeah. So, I mean, this is a big shift, right? I mean, we're going to be looking at internal process changes for large companies that are going to have to adapt, right? They've been doing clinical trials, they've been doing R&D in a particular way for the last 50 years. And now
Yes.
we're getting, because of this entanglement, right, that the experiments that we're doing on a single molecule or a single atom they shift because we're now able to see the interactivity, right? Or even kind of create races among these different, I mean, speed races really among these molecules to see who's going to cure cancer first, who's going to, right? We're able to process vast sums of DNA. Like I think about when I visited the super collider at CERN, what was most fascinating wasn't so much the solutions that were being created, but all the new questions that were being created. What do you think about corporate innovation teams who are going to look to incorporate this work inside of their processes? What are things they should be thinking about in terms of what needs to shift in order to prepare for introducing quantum computing into their day-to-day? Is that too narrow a question?
No, I think most, at least science and research heavy companies and industries need to already start thinking about framing, getting their minds around what is quantum computing, how do I use it in my company, and how do I set up the first teams that can start experimenting with it. So when the compute power is here and there, I know how to define my corporate challenges that I want solved that I can't solve today by how to describe the use cases that I want solved. We also talk a lot about, because we're still so early in the industry, a lot of people talk about, well, what is the best use for quantum computing? I don't think the killer app has been defined or yet. I think that will maybe over the next 5 to 10 years. How do we make the best use of quantum computing? And there's most likely not one killer app, but I don't think any of the killer apps that we can use quantum computing for is necessarily defined yet. But I definitely know there are some smart people at, like you said, at NASA, Department of Defense, big corporations like Pfizer, and so that are good at posing the right questions of what can we use it for and what should we use it for. And it's highly complex.
What scares you, if anything, Jesper, about quantum? What is
like anything
runaway capability?
Yeah, well, anything that you can use for good, you can also typically use for bad. That's if people have bad intentions, a lot of people talk about, well, quantum is going to be able to break Bitcoin encryption and all these things.
All the cybersecurity protections, right? That exist
cybersecurity.
on
I
normal.
wouldn't be too nervous about that because NIST in the US, who sets the standards for, amongst others, you could say, IT industry and the internet, are developing things or technology that not even quantum computers will be able to break. But there are other things, and people that had bad intentions are also very creative, unfortunately.
You worked in government long enough to know it, Jesper. Yeah, you've seen some things, right?
So there's a lot to be scared about, just like there is with AI now. I just think we have to constantly be mindful about how we create the policies around this, how we regulate it, so it's not a free-for-all, that it's a regulated space. And I'm not advocating over-regulation, just that it's a regulated space that makes it safe for humanity to work with, just like with AI. I think it's super important.
Yeah, well, I nominate you to lead that global international community to figure out what those standards should be and what should be regulated, Jesper. So the other part of this is, what are the things that we should be aware of? Like maybe if we're starting to examine, if I'm a chief innovation officer rather, in a Fortune 500 pharmaceutical company, is my best bet to look at startups who are operating in the quantum space, like Adam? Am I looking to make alliances with other companies where it might be good for a coalition of pharma companies to work together on solving something? Am I looking for a joint public-private partnership to get access to really big quantum computing resources? How would I proceed, in thinking about my next steps?
Well, there are not at a level two, I believe, but there are cloud providers of quantum compute out there. So you can start playing around with quantum compute, learning how to code for the algorithms and all these things,
Mm.
or code the algorithms. But I think if you're in a Fortune 500 pharmaceutical company, I think most of them are already, my guess would be that they already are playing around with this, or at least thinking of it and starting to make strategies around it. Because the next step would be from AI into quantum, and once we fuse these or combine these in a hybrid, these will just make AI probably even more powerful and strong in the sense that it is today. But again, the key is a little bit back to, if you are Pfizer and you're trying to define a pharmaceutical cure to some fatal illness, how do I describe that in a quantum context? Because it's not just regular thinking. You have to engage a team of, I would say, quantum experts inside the companies. I would say a minimum of team of 3 to 5 to make the first endeavors into quantum into a large corporate, and then you need to start to engage the rest of the company as to what are the challenges we have. Are you willing to put them on a quantum platform and try or work around with it, or is it too confidential at this point? But I also think you have to. But then, of course, there's always the option of having your own system or doing something else. I know there are companies that are, you could say, playing around with potentially having their own system at an early stage, so they can engage with it more. And there are, for example, I know in Europe, there are, you could say, consortia of large corporates that exchange knowledge on what they're doing in quantum. I think there's a consortia in Germany called QTech, but it actually which has companies like BMW, Airbus, Total Energy. I hope I'm naming the right ones, but I think so. So not just German companies,
Yeah.
but 14, 15 companies that are knowledge exchanging on what they're doing in quantum, keeping each other up to date, and really, thinking about when is the right time to start being even more active. I know a lot of them. For example, we know that Airbus is actively working with quantum. There are also a lot of US large corporates, Lockheed Martin and so on, that have active quantum teams. I do
It
think,
always goes to defense, doesn't it, Jesper? Like, like one of the biggest things that I kept hearing about, whether it was the Bifrost Summit or whether it was at TechBBQ, was this dual use, right? Which is
yeah.
everyone's looking to figure out what works for defense, what works in the commercial sector, and vice versa. That's a
I
big
also think
conversation.
so. The current level 2, you can experiment with it. The current level 2, you can calculate a lot on what we would say is not very complex molecules.
Mm.
Once we go to a level 3 or level 4, probably level 4, then it becomes really interesting to pharmaceuticals. But if they want to be ready for when the level 4 is, like I said before, then they basically have to start now. It's pharmaceutical industry. We always know it's something with long timelines and everything, developing drugs and a lot of research. And if a level 4 is, I'm not putting my head out, but let's say level 4 is 5 years away. 5 years
Okay.
away is not a long time.
Nope.
That's literally around the corner.
Mm.
If you say in 5 years there's a 100,000 qubit system, then you can truly start calculating something on complex molecules like they usually work with on the pharmaceutical side. So,
Well, Jesper, we're getting to the end of our conversation, and I want to make sure that I leave time to ask you the 3 questions that I ask everyone who comes on the show. So, in your mind, what is the greatest innovation of all time?
The greatest innovation of all time. I think for its, and that's a project as well as its innovation, because there's a lot of innovations involved, was probably the Apollo program.
Everybody loves NASA on this show, by the way.
They are very innovative.
Yeah.
I've been to.
Well, as a follow-on to that question, if you could join any innovation team in human history, which team would you have liked to have been on?
Any innovation team in human history.
Hmm?
It all becomes very recent. I think actually what I would almost say the one I'm in right now.
Aren't you lucky?
Yeah. And if I have to mention something else, I would probably say, having been part of NVIDIA from the very beginning and seeing the AI journey that they've been on, would also be truly amazing.
Yeah. Okay. My last question is, what is the innovation that the world needs now?
The innovation that the world needs now. That's not an innovation. That's more personal, but it's peace. The world needs peace. It almost seems like innovation nowadays, but the innovation, something, let's say something that can support peace building across nation, religions, cultures, all these things. It doesn't exist, but it would be an innovation.
I thought that's what the UN was for. Wasn't that the original charter?
Yes, and I think they were working very hard at it, but they haven't done the innovation to crack the code for that. I think
I know us humans are very challenging folks.
yeah, maybe AI and quantum can help with that at some point.
Yeah. Jesper, if people want to get in touch with you after hearing this conversation, what's the best way for them to connect with you?
On my email, I would think. Should I mention it now?
Sure, or LinkedIn, whatever you prefer.
Yeah, LinkedIn is my email and contact details are there. So LinkedIn, Jesper Kamp, Atom Computing. I think you would find me. There's not that many named Jesper Kamp.
Look at that. Around the world and now into quantum life. Jesper Kamp, thank you so much for joining me on the show today. I appreciate it so much.
Thank you, Susan. It was an honor to be here.
I truly hope you enjoyed today's conversation. If you did, be sure to like, follow, and subscribe so you never miss the next story that could inspire your own. And if you want to learn more about me or how I can help you and your team to become master storytellers to get your big idea to its finish line, head over to innovationstorytellers.com and schedule a call with me.